Okay, here we are. Today is day 14 on the advent of cyber challenges. Today's challenge is containers, DoorDasher's Demise. And before I begin, my little disclaimer as always, I am not a cybersecurity professional. I have no experience in or with cybersecurity, so you'll see me taking on these challenges as a beginner, just like other beginners would. Sometimes I stop, look things up, research it, so on and so forth. But with that being said, today is day 14. Let's go. Okay, so of course we have the two videos associated for this task/challenge. We do have two tasks today, task 1, introduction, and task 2, container security. I have not worked through this room just yet, so this is going to be fresh and all real time. So let's go ahead and see how this turns out. All right, it seemed as the sun rose this morning, it had already been decided that today would be another day of chaos in Wareville. At least that's the feeling all the folks at DoorDasher got. DoorDasher is Wareville's local food delivery site, a favorite of the workers and the best festival company, TBFC, especially on long days when they get home from work and just can't bring themselves to make any dinner. We've all been there. And boy, have we all been there. Well, one Wareville resident was feeling particularly tired this morning and so decided to order breakfast, only to find King Malheur and his bandit money battalions had seized control of yet another festive favorite. DoorDasher had been completely rebranded as Hopperoo. All of the Ware's favorite dishes had been changed as well. Reports started flooding into the DoorDasher call center. And not just from customers, the Health and Safety Food Org was on the line too, utterly panicked. Apparently, multiple Wareville residents were choking on what turned out to be fragments of Santa's beard. That's disgusting, okay? Wareville authorities were left tangled in confusion today as Hopperoo faced mounting backlash over reports of culinary impersonation. Customers across the region claim to have been served what appears to be authentic strands of Santa's beard in place of traditional noodles. A spokesperson for the Health and Safety Food Bureau confirmed that several dinners required gentle untangling, and one incident involved a customer achieving accidental facial hair synchronization. Anyway. Immediately, one of the security engineers managed to log on and make a script that would restore DoorDasher to its original state. But just before he was able to run it, Sir Carrotbane caught wind of his attempt and locked him out of the system. All was lost until the SOC team realized they still had access to the system via their monitoring pod, an uptime checker for this site. Your job as a SOC team member of DoorDasher: can you escape the container and escalate your privileges so you can finish what your team started and save the site? So our learning objectives today is learn how containers and Docker work, including images, layers, and container engine. Explore Docker runtime concepts, so the sockets and daemon API. And common container escape privilege escalation vectors. Apply these skills to investigate image layers, escapes a container, escalates privileges, and restore the DoorDasher service. Do not order Santa beard pasta. So connecting to the machine, we need to review the questions and the connection card shown below. So VM and split screen plus attack box. Do I need the attack box today? Yes. VM today? Yes. Split screen? Yes. Direct link? No. Credentials provided to connect to the VM via RDP, VNC, SSH? Also a no. Okay. So we're going to start the lab by selecting Start Machine for the target machine. We'll do that here. That will take about 2 to 3 minutes to load. In the case the machine is not visible, click the Show Split View button. There it goes. At the top of the page, once the machine has loaded, you should be given access to Mr. Bombastic user. Is that a Shaggy line? You will be given commands to run on the virtual machine in the next task. Additionally, start the attack box by pressing Start the attack box. Note, it's recommended to open both machines in full screen view. Okay, so let's do this. And let's do this. So we have our target machine first, attack box second. And let's exit split view. I think that's the target machine. Oh, it opens up in both forms. So we'll just leave this one here. This one's still loading. Okay. Note, it's recommended to open both machines in full screen view using the small icon, which is here. And then of course we can exit split screen here, and let's move on. We do have our attack box IP here, target machine IP here. Yours will be different from mine. Task 2 is container security. So what are containers? To understand what a container is, we first need to understand the problem it fixes. Put plainly, modern applications can be quite complex. So we have installation, troubleshooting, and conflicts. Installation, depending on the environment the application is being installed in, it's not uncommon to run into configuration quirks, which make the process time-consuming and frustrating. Oh, lovely. Here we go. Troubleshooting, when an application stops working, a lot of the time can be wasted determining if it's a problem with the application itself or a problem with the environment it is running in. Conflicts, sometimes multiple versions of the application need to be run, or perhaps multiple applications which need, for example, different versions of Python to be installed. This can sometimes lead to conflicts, complicating the process even further. So if reading these problems, your brain conjured up the word isolation as a solution, no, it did not. It conjured up, I think, frustration as a solution. Well, you're on the right track. Containerization solves these problems by packing applications along with their dependencies in one isolated environment. This package is known as, well, a container. In addition to solving all the above problems, containerization also offers further benefits. One key benefit is how lightweight they are. To understand this, we will now take a brief look at a container architecture, containers versus VMs. To illustrate container architecture, let's examine another form of virtualization, VMs or virtual machines. VMs like the ones you have been booting up in this platform throughout the advent of cyber. So right here we see app 1, bins/library, guest OS, hypervisor, and infrastructure. That should be a VM or machine virtualization. Containers, here's the app 2, here's the app 3. They're all packaged up. Then we have the container engine, the operating system, and the full infrastructure here. So a virtual machine runs on the hypervisor, software that emulates and manages multiple operating systems on one physical host. It includes a full guest OS, making it heavier but fully isolated. Containers share the host OS kernel, isolating only applications and their dependencies, which makes them lightweight and fast to start. Virtual machines are ideal for running multiple different operating systems or legacy applications, while containers excel at deploying scalable, portable microservices. So applications at scale. Microservices are a switch in the style of application architecture where before it was a lot more common to deploy apps in a monolithic fashion, built as a single unit, a single code base, using a single executable. More and more companies are choosing to break down their applications into parts based on business functions. This way, if a specific part of their application receives high traffic loads, they can scale that part without having to scale the entire application. This is where the lightweight nature of containers comes into play, making them incredibly easy to scale to meet increasing demands. They became the go-to choice for this increasingly popular architecture, and this is why over the last 10 years you have started seeing the term more and more. You may have noticed a layer labeled container engine in the diagram. A container engine is a software that builds, runs, and manages containers by leveraging the host system's OS, kernel, features like namespaces and C groups. One example of a container engine is Docker, which we will examine in more detail. Docker is a popular container engine that uses Docker files, simple text scripts, defining app environments and dependencies to build, package, and run applications consistently across different systems. Docker is the container engine of choice at DoorDasher, and so is what we'll be interacting with in our interactive lab. I'm sorry, I don't know why the wording tripped me up there. So Docker. Docker is an open source platform for developers to build, deploy, and manage containers. Containers are executable units of software with which packages and manage the software and components to run a service. They are pretty lightweight because they isolate the application and use the host OS kernel. I'm going to pause here for just a moment. Let's see what our questions are down here. So we have, what exact command lists running Docker containers? What file is used to define instructions for building a Docker image? And what's the flag? Bonus question. There's a secret code contained within the news site running on port 5002. This code also happens to be the password for the deployer user. They should definitely change their password. Can you find it? Oh, dear gosh. And then list the content. We have plenty more, where this came from, and container vulnerabilities room. Yeah, I got a feeling I'm not going to love this one. All right, a container escape is a technique that enables code running inside a container to obtain rights to execute on the host kernel or other containers. So give me just a moment here. We have our attack box fully loaded and our target machine as well. This, I believe, is our Docker container. Sorry, I'm just trying to get a feel for what this is here. Ubuntu Pro delivers the comprehensive open source. Oh, is this a server? Ubuntu server, maybe? Applied, one additional security. Mr. Bombastic. Okay. And so escape, I'm just going to reread this. A container escape is a technique that enables code running inside a container to obtain rights or execute on the host kernel or other containers beyond its isolated environment, known as escaping. For example, creating a privileged container with access to the public internet from a test container with no internet access. Containers use a client-server setup on the host. The CLI tools act as the client, sending requests to the container daemon, which handles the actual container management and execution. The runtime exposes an API server via Unix sockets, runtime sockets to handle CLI and daemon traffic. If an attacker can communicate with that socket from inside the container, they can exploit the runtime. This is how we would create the privileged container and internet access as mentioned in the previous example. So the challenge. Your goal is to investigate the Docker layers and restore the defaced Hopperoo website to its original. So this is going to be one that's not user or beginner friendly again. Is that what I'm thinking already? Your goal is to investigate the Docker layers and restore the defaced Hopperoo website to its original service DoorDasher. We are going to walk through the steps to beat this challenge together. Oh, thank goodness. Now it's time to start using the machine you booted up in task 1. Let's check which services are running with Docker. Run the following commands. We're going to do Docker PS. And of course, why would they tell us what that means? Duck.ai. Let's pull this up. In Docker, what does the command Docker PS mean and do? So the command Docker PS is used in Docker to list all the currently running containers on your system. It provides a summary of active containers, including important details like the container ID. Of course, why would we explain that? So we're going to do Docker PS. And we have names here. So deployer latest, deployer, Dasher app latest, Dasher app, uptime checker, Wareville times. So it looks like 1, 2, 3, 4 items. You should see a few services running. 1, 2, 3, 4 items. The main service runs at HTTP, followed by this IP here. So explore the web application and notice the defaced system, Hopperoo. We know DoorDasher is a food delivery service. Let's explore uptime checker. Sounds interesting. So let's click into this one here, our attack box. Wait for that to load. Open our browser. And then sugar honey. Paste. Go. Welcome to Hopperoo. Search for restaurants. Okay. It's like definitely bugging out here. I'm like scrolling just a little bit and it's like flipping out. Okay, let's go back. So we're going to run the following command to access the uptime checker container. So we can run this command here. Control C. Go back to this one here. It sucks that it's got to keep loading each time. We're going to paste it. Nice. Nothing worked. So I assume we're going to run this one instead. So docker execute -it uptime checker. Holy moly, let's see if I can get the whole thing here. Control C. Let's paste that and let's run this instead. Okay. After logging in, check the socket access by running. Nope, we just want to grab this. And paste this here. We're going to run that. Here we see /var/run docker.sock. And the Docker documentation mentions that by default, there is a setting called Enhanced Container Isolation, which blocks containers from mounting the Docker socket to prevent malicious access to the Docker engine. In some cases, like when running test containers, they need Docker socket access. The socket provides a means to access containers via the API directly. Let's see if we can. Your output should look something like, yes, it does. And I wonder what happens if we try to run Docker commands inside the container by running Docker PS again. So we're going to do and we still see deployer, -app, uptime, and whereville times. All right, and we can confirm we can perform Docker commands and interact with the API. In other words, we can perform a Docker escape attack. Let's instead try to access deployer container, which is a privileged container. Run the following command. So we're going to run this command here. And enter. So now we're at deployer at B4509956C6E9, and then it looks like in the application. All right, so now we're going to type in who am I and check which user we are currently logged in as and exploit the container and find the flag. So who am I? We are deployer, okay. Okay, we made it, and we've managed to make it to the container where the script to store the site to its former version is save the day, run the recovery script in the root directory to recover the app using sudo. Okay, so I guess copy this, paste, and switching to DoorDasher's skin, Copying version file to Dasher app container successfully copied. Restarting Dasher app container. Dasher app recovery complete. DoorDasher has been restored. The hackers have been defeated. Well, I don't see a flag. With that, you can see for yourself by refreshing the site. And as a reward, you should be able to find the flag in the same directory as the script, which you can read using the cat command. Am I confused on that? So cat this script maybe? So let's do cat ps recovery script. We'll do cat recovery dot script dot sh. Oh, it's underscore. Cool. Let's refresh the page. Okay, it's back to DoorDasher. What exact command lists running Docker containers? Well, that was Docker ps. What file is used to define the instructions for building a Docker image? What file is used to define the instructions for building a Docker image? Let's see. That sucks. It doesn't look like I can see anything here, so we'll do Docker ps. Was it uptime? Nope, it's not going to be uptime checker. Is it this one? Well, I don't know the flag. So type who am I. With that run, you can see for yourself by refreshing the site. As a reward, you should be able to find a flag in the same directory as the script, which can be read. File, was it deployer? Deployer? No. Was it Dasher app? Also no. Well, I am not certain. I can't even do the bonus because I can't locate the flag, nor can I figure out what file is used to define the instructions for building a Docker image. What file is used to define the instructions? Is it this one? There's no way, that looks way too long. Yeah, it's not going to be that. Docker, maybe this one? I don't know. Mm-mm. Let's copy this. Control C. Docker file. I guess we can try that, but I highly doubt that's it either. I don't know, maybe I'm wrong. Docker file. Okay, no, that was it. Nice. But what's the flag? As a reward, you should be able to find a flag in the same directory as the script, which can be read using the cat command. Apply VPNs, banner sh. Well, okay, we made it. As a reward, you should be able to find a flag in the same directory as the script. I have no clue what that even means. And I don't assume it's on this one here. Let's see if we can look for that item on 5002. So bonus question, secret contained within the news site running on port 5002. This code also happens to be the password for the deployer user. They should definitely change their password. Can you find it? Okay, so all the red highlights, 1, 2, 3, that's the password. Only thing I'm not understanding is where we find the flag. So we ran the command. With that run, you can see for yourself, which we did. As a reward, you should be able to find a flag in the same directory as the script. Okay, I'm going to close this. I'm going to open this back. Do an ls cd into scripts. Ls again. We're going to do cat banner. Nope. Cleanup, display IP, start bh.shell, cleanup shell, banner backup shell. I have no idea. There's no way it's on this machine. Okay, I might have to take a pause and go watch a quick snippet here and figure this out. So I'll be right back. Okay, I'm back. I think I might have figured it out. I'm going to copy this and just go back into that instance. And let's take a look inside here. I thought we did and there was nothing. Okay, can we print the working directory? Yes. Can we go back? Yes. Can we look inside there? Yes. Ah, I see a flag.txt. See, this is what I mean. This is not beginner friendly. It should have said that, hey, try going back one directory and looking while in the deployer user. And there we go. THM Docker escape success. That was not a success. Or maybe it was. I don't know. Paste. Check. Holy moly. Continue. Oh, look at this. We're actually going to get a ticket today. Nice. And let's go back here. We're going to terminate. And terminate this one. Close this out. Make certain this was closed. I'm not 100%. There we go. And that's going to be it for day 14.